Okay, so I'm still working on this. I'm still setting out this one. Okay. All right. I'll move to the next one. So I'll go ahead and fix the third one. Okay. So this time around I'm going to use this down here to see if they are the same height. Okay, so I get it now. Set out at the same height now. Okay, let me check this side. Okay, I'll go in a bit. I'll go in a bit. Then I'll check again. Let me check here again. Okay. Let me use this to lock it for the meantime. Okay. Okay, so the mortar is a bit soft, so let me wait for some few minutes before I'll be able to use my spirit level to know its straightness. For now, we'll just leave it for a while. I'll just leave it for a while. Check in it here. So now we'll lift this one up a bit. And here this, I'll drop this a bit. We're gonna go ahead and straighten this. This side. the mortar is already hot here. Kind of okay. Let's see, it's okay. Check that. Okay, let me check the side. This side. Let me check this first one again. Check this. And this side. Okay. This side. Let's see. Okay, this side is okay. Then finally, I need to drop this. I need to drop this. I need to drop this. Okay. Still need to do some kind of adjustment. So, adjust it good. Okay. This okay. It's okay here. It's okay here. Then to this side again. Okay, then finally down one more time. Okay. This will go down. This will go down a bit. Okay. And every time you shift it downwards, the level thing changes. So now here it's fine, perfect. But here wouldn't be the same. I need to set it again. So it takes time, like I said, it takes time. If you're not patient, you can't work on this. It takes time. Okay, and again, I'll check here. Again, I'll check here. Okay, I'll check here again. I'll check again. Check again. And again. Okay, so like I said, this is not something that you just get up and do. So you can see there's some kind of labeling in there. Okay, so this one-story building, and so I have done it such a way that this will be for the downstairs. Okay, so all the circuits downstairs, they are coming into this distribution board. Then this upstairs 220 volts. Okay, so in this case there's 220 volts downstairs and there's 220 volts upstairs. Then here we have 110 volts and we have the upstairs and downstairs. So for the 110 volt system is going to this is going to be the combination of the circuit downstairs and also circuits from the upstairs. Okay. And so here, why these holes? Okay, so I've done it such a way that let me see, such a way that I'll be able to, I don't know, I'm going to lay pipes down here, but who knows, the pipe might be full. So this is some kind of backup space for me to be able to draw my 16mm square cable through here from the distribution board, through here, then through here, then to this side. Okay, to this side. Okay, and this is going to be various PVC pipes. For this it's upstairs, so there's no down here, and this the 110 volts, those circuits coming from downstairs. Okay, so a couple of things to consider. So one thing you need to know about this way of going about distribution board is these are metallic. And you know, anything that is metal will not last forever. So these, when they go in there, it will take some time, though it will be in the walls or in the wall for some time, but definitely it's going to last one day. And also one important thing about this setup is, you know, technology is fast advancing. We are using this type of breaker. So this is a miniature circuit breaker, or what we call MCB. Some few years ago it wasn't like this. It was some type of fuse and some other type. All these, they have phased out of the system. So who knows? Technology is fast advancing, and who knows if there's going to be. So in the case whereby this MCB technology is out of the system, and maybe probably, you know, for example, MCB is more safer than those fuels and those old stuff. Okay, so this will be able to trip off, let's say, a short circuit or some other electrical faults faster than those fuels and other stuff. Okay, and so who knows, one day this will be phased out, and meaning I need to come and chisel or cut all these walls, because at that time this will be plastered, painted and stuff like that. But Because it's fixed into the wall, I will need to come back to chisel it or cut the wall. This we first cut it with a cutting machine or angle grinder. We first cut it, then we will chisel it to our how we want it. So in the case of this getting out of the system, this whole thing must be removed from the building or from the wall, and a new setup will be fixed here. So this one of the major things that you have to consider. You have to consider when you are going this way, that is fixing the distribution boards into the wall. This is kind of very simple and very easy in your power room or in your house, but in the long run, who knows, tomorrow new technology will come in, or probably this is metallic and it might rust and you will need to change it, and there's going to be a whole lot of work, because at that time everything is done. You will need to come and cut, you need to do this and stuff, you need to fix it back again, replastering, repainting, and a whole lot. So for me personally, what I usually recommend is let's say you just go about, you do all your setup, then finally, let's say during the final stage of that is installation of electrical fittings and stuff, you can just, we have a way of building some kind of a big board that will be able to contain all these distribution board or all this setup. And so that is simple. So for that one, when you fix your board and you fix these distribution boards on it, it's just a matter of time. Let's say this will face out of the system. You just take it out from the board, you change it, you fix it back without any chiseling work or anything like that. Okay. But apart from that, this is cool when it's actually fixed into the wall. It's really cool and it's really nice. It's really cool and it's really nice. So there's some sort of electrical discipline that I want to share with you today, and it's basically simple. Like I said, you need to sit down to plan. You need to know how to go about your circuit, and also you can see that these are various sizes. Why is it that I'm using 220 volt downstairs? I'm using like a bigger one. This is a 12-way 3-phase, and this 8-way 3-phase. This 8-way 3-phase. Okay. So before I was able to come to a decision point, I needed to count all the circuit. That is the various socket outlets, lighting circuit, ceiling fan circuit, water pump, gate automation, and so many other stuff, air conditioners, water heaters, all these circuits. I have considered all these circuits. That is why I have this for this, I have this for here, and this for here. You don't just get up and select any distribution board that you think it's okay. You choose what will be able to contain the circuit in the facility, and also you need to you need spare in this. Okay, so like this, I will have something like let's say 6 or more spares in here. That is free breakers for additional points, additional circuits later on. You know, when you are doing something, you are working on electrical, you don't know what might happen in the future, so you make provision for a whole lot of things. Even some kind of circuit that you are not aware of, you don't, let's say it's this the exact number is let's say 12 circuit. I don't put a 12 circuit or a 12-way panel here. Otherwise, in future, if there's going to be expansion, circuit expansion, where are they going to fit? Meaning they need to take this thing out. But I have made provision for additional. This has, let's say, 8 or 10 additional breakers that will be free here as well, here as well. So this is basically something simple, and I know you can do it. Yeah, maybe probably you are doing it, maybe you don't do it right, but it's possible, you can do it. Okay, so don't forget to subscribe or follow, and I'll see you in the next video.